Welcome to my chemistry channel, B.L.DASH short and sweet in chemistry. I hope you are doing the best in organic chemistry. Today I will see the resonance structure of the ortho-nitrophenol and para-nitrophenol. Whereas meta-nitrophenol is there but it not existing properly, because meta-nitrophenol has no resonance structures. Now, ortho-nitrophenol and para-nitrophenol, they are famous and they are very important to our daily life. When ortho-nitrophenol is existing, by removing H plus ion, it produces ortho-nitrophenoxide ion. Similarly, in para-nitrophenol, if hydrogen ion is removed, and now it shows para-nitrophenoxide ion. We will see here what are the possible resonance structures in ortho-nitrophenol and para-nitrophenol. You know, ortho means 1 and 2 position, para means 1 and 4 position. Now see here, first one, ortho-nitrophenoxide ion, because here H plus ion is removed. And now if you forget this arrow mark, you see this is the phenoxide ion in 2 position, that is ortho position, that is nitro group is there. In nitro group, see here properly, 2 oxygen atoms are there. In one oxygen atom, double bond is attached, whereas other oxygen atom is attached by single bond having one minus sign, negative sign. So how many electrons here existing? 6 electrons are existing, and here two, that means 2 pair of electron existing, because there is one double bond. And now we will see, let us start what are the possible resonance structure. Since the minus sign is there, and here one pair of electron moves towards this bond, single covalent bond. Now what happens, since it is giving pressure to this bond, covalent bond, automatically this double bond, that is unstable, and immediately the pair of electron, that is pi electron, is localized to this carbon. Then automatically the next resonance structure becomes he or she. Since the electron moves to this carbon, that is why it exists as a pair of electron having negative sign, and so the double bond is not present here, and as it is here double bond you can represent, and now immediately the pressure indirectly forced to this pair, that is pi bond, and here this pi bond is localized to the delocalized to this oxygen. Automatically what happened next? Since there is excess of electron, pair of electron having negative sign, and this electron also moves through near sigma bond, that is covalent bond, and so next structure, what is the possible next structure? Here you can see, since the electron delocalized to this bond, so automatically it gives a pi bond extra, that is having double bond. And now since the electron delocalized, pair of electron delocalized to this oxygen, that is why double bond changes to single bond. This double bond changes to single bond, and here having minus sign. And here automatically before that you can say there is a double bond, and since there is a negative sign, and automatically here the pair of electron moves to the adjacent sigma bond, so the electron delocalized to the sigma bond. Here also you can observe, since there is a double bond, single bond changes to double bond by the delocalization of the electron, so here the bond automatically moves to this sigma bond, and it gives, next you see, it gives a pi bond here. And you can show here, since the electron moves, so that is why it becomes double bond, and here pair of electron, 2 pair of electron present, and here having minus sign. That means here it is having minus sign, here it is double bond, and N now acquires before as it is shown by N plus positive sign. And after that you can observe, since the pair of electron or the pi electrons delocalize to this carbon, adjacent carbon, that is why it acquires a single bond, negative sign with a pair of electron. And see, all are clear. And since the negative sign having pair of electron moves to the adjacent bond, or here this pi bond, pi electron moves to the near adjacent carbon. So next resonance structure, here it becomes to having pair of electron negative sign, and since the electron moves to this bond, here you can see, so it changes to sigma bond. One sigma bond is there and it one changed to pi bond. That means there is a double bond existing here. Since again here pair of electron having negative sign, so the pair of electron delocalize to the adjacent bond and automatically gives the pressure to this near carbon, and near, that is pi electron is present, pi bond is present. That is why this pair of electron, pi electron, delocalize to this oxygen here. So next structure becomes, since it moves towards this bond, so it is double bond, and since this pi electron moves to this oxygen, so it acquires a negative sign. So you can see the first, this side and this is double bond, that is pi bond, and according to Kekulé structure, lastly you can find here this double bond existing like this. And here here also here you can represent as N plus and O pair of electron, and similarly here O, that is 3 pair of electron having negative sign. And again lastly it changes to here this bond delocalize to this bond, so the structure is like this, and here you can show an N plus O and two pair of electron, and here 3 pair of electron and having negative sign. So here you can see how the resonance structures are possible in this ortho-nitrophenoxide ion. Again you see, again start from the beginning. Since it is negative sign, so pair of electron with negative sign moves to this, and here the double bond existing, that is pi bond existing, so here the pair of electron moves to this carbon, so it acquires a negative charge having pair of electron, and this pair pi bond is there, so this is delocalized to this oxygen here, and now here this carbon having excess of electron having negative sign, so delocalized to this adjacent bond. Similarly it acquires a double bond, and since it is excess of it is having minus charge, so the pair of electron delocalized to the adjacent carbon, and here since it moves to this oxygen, so it acquires 3 pair of electron having negative sign. And after that you can see this pi bond moves to this adjacent bond, and this adjacent bond, this pi bond, the electron moves to this carbon. That is why the structure you can see, that is, since it is delocalized to this, so it occurs a double bond having 2 pair of electrons, and it is as it is before, and it is also as it is before, and now it acquires a negative charge having pair of electron, and here a negative charge changes to negative charge pair of electron, and last stage here the pair of electron having negative sign delocalized to this adjacent bond, and this pi bond moves to this oxygen. So lastly the structure represent that is a Kekulé structure of this. So these are the resonance structures possible. You know, as many as resonance structures are there, and that is a stable compound. para-nitrophenoxide ion. What is para? Mean 1 and 4 position, and here phenol, that group is 1, and nitro group, that is in 4th, so it is ortho-nitrophenol. When hydrogen is removed, it gives para-nitrophenoxide ion. And now instead of ortho, that here existing nitro in 4th position. So again see, compared to ortho-nitrophenol, the same process. Here the pair of electron moves to this adjacent bond, and this pi bond moves to the adjacent carbon, and as the nitro group remain as it is, and so it becomes here double bond having 2 pair of electron, and it acquires a negative charge with a pair of electron, and here it is delocalized to this adjacent bond. And now this pi bond, that will give force to this bond. Automatically what happened? You can observe it acquires a, sorry, not this bond, this carbon, this point, this carbon. So it acquires a negative charge, having, you can write also, having a pair of electron. Then what happens here? So automatically the structure, next structure, it is double bond, and this moves to this, so it is double bond, and this pair of electron moves to this, so it acquires a delta negative having pair of electron. So here the pair of electron negative sign moves to the adjacent bond. So, and you observe here, since there is a double bond with oxygen, so the pi bond electron moves to the oxygen. So what is the next structure? Since this pair of electron negative sign moves to this, automatically it acquires a double bond, and it is remain as it is. Since a pair of electron moves to this side, so it acquires a negative charge, and since the pair of electron negative sign moves to this, so it acquires a double bond. Now what happened here? Since there is a double bond, it comes to this adjacent bond, and this adjacent here pi bond electron moves to this carbon, So next step what happened? It acquires a the pair of electron having negative charge, and here it becomes a double bond. So next case what happened? Here this electron pair having negative sign moves to the adjacent bond and becomes to double bond. And since the double bond is there, last stage it acquires a single bond having negative sign. So as it is, the ortho-nitro group remain here same, and here since the movement of electron towards it, so it acquires a negative charge, and this is the para-nitrophenoxide ion. Here you can also observe there are so many resonance structures, so also it is stable one. Again see, when there is a minus sign, here the movement electrons like this, and when there is a double bond, the movement of electron to the adjacent carbon, and similarly the structure one by one proceed to near adjacent carbon and adjacent bond. The electron moves to the adjacent bond, and the pi bond, that electron delocalized to the near adjacent carbon and acquires. These are the resonance structures of para-nitrophenoxide ion and ortho-nitrophenol ion. Since there are so many resonance structure possible, so that is why they are stable and they are more acidic character than meta-nitrophenol, which is not totally, you can say it is not existing, because there are no resonance structures possible in meta-nitrophenol. I hope ortho-nitrophenol ion and para-nitrophenol ion, how the resonance structures are possible here, I hope it is clear to you, and hope you will like, share and subscribe my channel B.L.DASH Short and Sweet in Chemistry, so that further I will produce more resonance structure of different organic compounds which will be useful to you. Thank you all. Thanks.